my notes. What is partitioning? Partitioning is simply the breaking down of a number. Okay, 76, yeah? 76 is 70 plus 6. So the easiest way to partition a number is in the place value, which you should know about now. So 7 tens is 70, 6 ones is 6. Okay? If we move on to a 3-digit number, 364, we would partition this as 364. And typically, we put pluses in, yeah, to show that I'm adding my 300s, my 6 tens, and my 4 ones together to make 364. However, there is something to learn about partitioning. You can partition a number in any way you want. So, let's take 86 for example. Okay, 86. The most obvious way of partitioning 86 is 80 plus 6, which is in place value. But if you ask a child to partition it in a different way, you might have some children that go like this. Yeah, they may go. And as a parent, you'll go, surely that's not right. And then they'll go, and so forth. And I'll go, that is absolutely correct. They've got the concept that you can partition a number in any way. You might not want to do that because it's not very useful, but there are times that partitioning a number in a different way might be very useful. For instance, if I were to ask you to double 86 in your head, it's quite difficult to do. I can feel the heart rate's already going up. However, if I identify 86, yeah, as being 50 plus 25 plus 11, I suddenly go, actually doing that sum in my head, doubling it, becomes infinitely easier because I can double 50 to 100, I can double 25 to 50, 150, and double 11 to 22, yeah, and I get 172. Hope that's right. So you can see actually by partitioning a number in a different way, I actually can do maths easier. The other way is, and it's not a traditionally taught one, but it's good to recognise that 86 could also be identified as 90 minus 4. Again, it's not a traditional way of looking at partitioning, but it's just something to remember because in some of the maths later on, your child might see it like that, so it's good to actually have that in your head. Where could that be? Well, probably not an 86, but if I were to say to you add 97 and 97 together, those amongst you in your head might find it easier to go, well, that's 100 plus 100 minus 6. So you identify the fact that 97 is 100 minus 3. Hopefully this is all making sense, but this is just how we are teaching our children today to see numbers differently than the way we saw them as a whole unit. So we only ever saw 86 as 86, whereas our children see 86 as built up of different ways. So built up of 8 tens, 6 ones, or indeed 50, 25 and 11. Okay, hopefully this is making sense and hopefully you've got an idea of what partitioning is. I should point out, I'm following my notes, this is a booklet that's about to be published, so you've got this video and booklet to read. Okay, so when you go on to then looking at how you use partitioning to add and subtract, you can see that you break down the number, you do the individual parts, and then you put it back together again. So I'm just going to do this example, 35 plus 23. Okay, so 35 plus 23, what I split it down as is I split it down as 35 equals 30 plus 5, 23 equals 20 plus 3. Okay, I then add my tens together in whatever way. I can use my fingers, 30, 40, 50. And I add my ones together to get 8. And then I put my number back together to get 58. Okay? There is another way in which I can write that. So that is it kind of in line form. I quite often do it like this, which is 35 is 30 plus 5, 20 is 20 plus 3. I add my tens together to get 50. I add my ones together to get 8, and then I put my number back together. Some children might write it like that. Okay? It's perfectly correct. It seems like a long-winded way of doing it, but it actually is the building block to getting that understanding to moving to the columnar. Okay? And it is an important stage. Okay. So the next one is 96 minus 72. Okay, 96 minus 72, I'm going to do it this way, 90 plus 6, 70 plus 2. Okay, I take away, 70 from 90, I can count back and I get 20. I take 2 from my 6, I get 4. I put my number back together and I get 24. I feel a bit like Carol Vorderman at the moment. She's one of my heroes. Right, so there you go, there's subtraction. Now, those amongst you might be saying, I see I've got a question about this. Okay, so here's the one I always demonstrate, 63 minus 29. Right, so I'm going to do it the same way as I started, 60 plus 3, 20 plus 9. I subtract my tens, I get 40. I subtract 9 from 3. I cannot do that yet. Okay, at this stage a child has not been introduced to the idea of subtracting into negative numbers, so I cannot do that yet. So what might I do differently? Well, we go back to what I said about partitioning. You can partition a number in any way to make it useful. So I'm going to look at 63 and I'm going to say, I'm going to partition that differently. I'm going to partition it as 50 plus 13, 20 plus 9. And now I can take 20 from 50 and I get 30. And I can take 9 from 13 and I get 4. And then I put my number back together and I get 34. Okay? You see here that I partitioned it differently. Children will get this idea, yeah? They will know that they need to exchange one of their tens, yeah? So what they're actually doing here is saying, I'm gonna partition it differently. Instead of 60 and 3, I'm gonna do 50 and 13 because the 9 is too big on that side. And what I want to demonstrate now is if I were to write this in columnar fashion, 63 minus 29, yeah, what I would do is 9 from 3, I cannot do. I'll exchange one of my tens for 10 ones. So now I've got 13 minus 9 is 4 and 5 minus 2 is 3. And if I actually look at what I've got here, this is a shorthand version of what is here. I indeed have represented that I've got 50 and 13. And for the first time, I've got a way of explaining to a child what I do here. Yeah? So what I'm doing is I'm partitioning the number differently. I'm exchanging one of my tens here for 10 ones, so I've got enough ones to take away my 9. Hopefully that makes sense to you. If not, later this week I plan to do a Q&A session. So if you've got any queries or you need me to do anything, I'll go on live and you can email me your questions and queries and I will try and answer as many as possible. Okay, so that is partitioning. Just so you know, you can do this on a number line as well. Okay, some children will prefer to do it on a number line, but if I go to 63 here, and I take away 29, what I might do, if I'm very clever with numbers, is I might take away 30, count back 30, and then add 1. Yeah? Or I might go, count back in 10, 63, 53, 43, and then take off 9. Okay, count back in 9s. The next thing that we're going to look at, and it's just kind of a complete aside, and it's in the notes, so please read it in the notes. Quite often our sums are not, our addition and subtraction sums are not represented in the same way as we did at school. So I showed some blank rings to children in year 2 a couple of months ago, and I said, you know, what's that? And they knew straight away it was the whole part model. And I said, do you parents know what that is? And they went, no. And And I looked at it again and I said, actually, looking at it, it looks like a crop circle to a parent. But these are whole part models, hopefully you can see them. And they also use them as bar models. They're just different ways, and on this it explains what to do, but they're just different ways of representing the idea that a number is a whole number, has got parts that you can add together. And also it allows you to swap round, so you can, it's not just the whole that's missing, sometimes it's the part that's missing and you need to work out the sum to figure out how to work that one out. So just to let you know, that's in the workbook as well.